Okay, hello, my name is Matthew, and I'm going to talk about a project that I've been working on. I'm going to start not by with a project that I haven't been working on, which is Scratch. So just as an introduction to sort of the inspirations for what my main project is. So I did Code Club and I tried to teach some kids how to do some coding, and that goes all fine with Scratch. Scratch is very good. If you haven't seen Scratch before, you drag and you drop things in together and you can make like little bits of code quite easily with this nice sort of drag and drop interface. So if I do that and then I click that, suddenly the cat moves. I'm not going to go into too much depth. So if you don't know what Scratch is, then my project probably isn't going to make much sense. But the idea is, so you have this, and then you move on to teach children a more advanced programming language, like say Python or Java or something. And the problem is, of course, that it's quite different. It's quite a shift. I mean, the nice thing about Scratch is it's very plug and play. You just jump in and you can make things move straight away, and it's sort of nice, and it's got a nice sort of community with it. You've got the sort of the Scratch website, you can share your projects. So I decided, I thought maybe an interesting project that I started quite a few years ago would be to try and make an intermediate step, a sort of programming environment that you can move on after you've mastered Scratch and you want to do something a bit more advanced. So the project that I have been working on, if I can find it, is this, which doesn't look anywhere near as exciting. That's actually the preferences. We'll come back to that in a second. So this is the basic. It doesn't look very fancy. If you're wondering why the windows look like Windows 2000, it's because I'm running Linux and I just quite like the square look, and I don't really like fancy new window managers, but that doesn't matter. So I'm not actually running Windows 2000 if you're just tuning in. So the idea is, this is a tool that's meant to also be an IDE. It's meant to have an image editor and everything built in, and it's designed so that you can basically move from Scratch into this and move on to more advanced programming things, but keeping with the same kind of feel of Scratch. So if I start a new project, which will come up here, we can do these. So this is the window. Where ignore the little pink dot in the middle. I haven't removed all of the debugging stuff. The pink dot just tells me that that's the middle of the screen. So this is a very much work in progress tool. So I've had a lot of work over the years, but it's one of these things that are going to take forever to get quite finished. So the first thing we'll do is we'll pick up a library. So you might think, oh, these are the sprites from Scratch 2. They are, in fact. You can actually transfer across the library sprites from Scratch 2, but when I release this, they will not include the library sprites, but I will give instructions on if you wanted to do that. Some of the things don't import across because of the weird SVG vector format file that Scratch and the way that I import them. So some of them look a bit odd, but we'll pick the cat. Alright, so now we've got a cat in our thing, so we've imported a sprite. So you may also notice another thing is that these are the icons from Scratch 2 or Scratch 3. I've ripped those off. When I release this, they won't be using those icons. But I'll come back to that later on. So now we have a cat, and we can go back. So the cat is in the middle of the screen. So again, ignore the giant green dots. I probably should have removed those. But I'm very professional, so I'm not going to. So you can move the thing around. So in this one, you can zoom in and out with the mouse wheel, and you can click in the middle and drag the screen around, or use the little scroll things. So you have all these things. You have the X position and Y position and all that. The major difference between this and Scratch is you don't write at the moment. with Scratch commands, with drag and drop, sorry, you actually use, I think my keyboard's going to be awfully loud. I'm going to go back to the press, and I'm going to change the font size to be 30. All right, and back to that's the costumes one. So the idea is, I want people to learn new languages, and you're going to do this by having an intermediate step between Scratch and the more powerful language. And so it's basically going to follow what Scratch does, but introduce more powerful programming things. So if you want to do what we did before, I can't actually remember. I think it was, well, it's on my screen, so it's on my other screen. So the code that I wrote beforehand was something along the lines of 10. I am going to talk about this language, so don't jump up and down and go, my gosh, he's got semicolons on the end of things. So don't worry, just chill, it'll be fine. And then we can turn, and now we can run it. Sorry, this is auto flag. Alright, and we can rerun it. I've gone and done that. It's doing the same thing over and over again. So this is running very much like Scratch. So I'm going to go through and talk about all the little bits and pieces that are going on here. So the one thing you may notice, there are actually little buttons over the side that match up, and you've got turn, forward. At the moment, these don't work quite the way that you want them to, but they do provide explanations and what the command are. So it will show you the command forward, but there's actually I don't know why I haven't put down the alternative. So in this case, you could write forward or you could write move. For turn left, you can write turn, I think it's turn left, for example. So this will eventually turn into a nicer, more useful tool for reference tool for what all the commands are, and you should ultimately be able to drag and drop them across. You can kind of drag and drop them across into here, and then you can build up weird things. So turn left, 101 the sensing things. Turn left, mouse down, but that isn't so useful at the moment. And also it uses the system drag and drop, so it doesn't look very nice at the moment. As I will get to at the end of this video, the one thing I really want is an actually nice editor. So at the moment I'm just using a built-in. This is built using Java and Java FX. So this is the standard Java FX editor. So it's not fancy. It doesn't do any color things. You can shift tab and you can comment things out. So it does have a few, and you can go to lines and find things. It does have a few editor things, but it doesn't have colors. And what I really want is I want to mix in a drag and drop interface. So you should be able to do a lot of drag and dropping like you did in Scratch, but you can just go in and edit it like text as well. So what would happen is you'll be able to double click, you'll click on repeat, and it will turn into a little block like Scratch, and then you can move it around within the document. Of course, because this is a text thing, it's only going to have up and down, so everything's laid out like a document. So there's not going to be any of that left, putting your blocks anywhere you want as in Scratch. So anyway, we're going to go back to the project. So you have the sprite layout, which is this thing here, and which works just the same way as it does in, you can change the start frame, so you can choose Cat B. You can click on the stage and hold on, go to default layout. I've actually forgotten how you change the background. Normally it comes up here. I'm not entirely sure how I'm going to get it to show up. Oh, it must have forgotten it. So it used to come up with the where is it? That's the start frame. Why is it down the bottom there? Okay, so that's the stage start frame. That should have come up over here. So yes, as I'm going to go through, there are quite a few things that don't work as they should. They have worked over the years. What has happened is that I've changed a lot of things and added new features, and some things have disappeared over the years. One major thing in the last year was that you can actually load multiple projects at the same time and go through and work on them. You can't quite drag and drop between projects, but that will happen pretty quickly. So you've got that. You've also got costumes. So this one's not very useful because they're SVGs. So at the moment, we can convert it to that. Go back to here. We can edit bitmaps, and I will have an SVG editor at some point. For some reason, it doesn't work. What's going on here? Oh, that's right. You've got to go draw. So draw. So one major thing that's I spent so long on this editor. Oh, so you can zoom in and out and move around like that. And if you zoom in far enough, it gets pixelated, and then you get a grid. So there are some drawing options. So you can draw a simple line like this, and you can turn off the pixel art, and then it will be anti-aliased, so like a normal thing. You can do the same thing with rectangles. I don't know if that works. It does work. Oh, that's nice. You can also do structured lines. So we'll change the color a bit to blue. We'll use that, and we'll come back out, and then we can draw a line, which has an annoying line. That should probably be removed. So one of the things with the drawing editor is it has evolved and changed so many times over the years. And so a lot of the drawing options that actually have been implemented are not showing up. They're just, I haven't got around to changing to the latest framework. Just a side note for people interested in how I programmed this. Originally I was using, because I used JavaFX, which is a graphics and GUI library for Java, which is all really good and fine, but it's not very good if you want to zoom in and do things like this, because it's hard to scale things in a way that isn't interpolated or aliased, so it looks a mess. So this is actually doing a lot of software scaling, and also the drawing tools are a kind of pain to work if you're doing a drawing editor. So the underlying drawing in this case here is actually being done with the original Java AWT graphics library, and then copying across, which worked out to be much better, which is one of the major changes recently. So before there was all this different types of environments for drawing pixelated things, and there was all this kind of different thing, and there was a different zoom window, and that's all changed over the years. But you can draw rectangles. So the rectangles look better because they don't have the annoying little lines, and also ovals and things. But there is also polylines and polygons and flooded fills and shifts and flips and all the kind of standard things, and cutting and pasting images and manipulating the images. They've all disappeared at the moment because I changed things around, and I have to change things in each category. And they also over here in a messy sort of looking area over here, simply because, you know, I'm always shifting things around and changing how it works. And at the moment, it's like I don't care. I just want them implemented and usable, and then I'll come back and make everything look nicer. There also used to be options so that you can type in where the corners and everything are. So one thing that I spent a long time on, which is probably completely pointless, is that I spend a lot of time on how you can edit the shapes. So you can obviously drag the corners like this, and you can click on that, and you can rotate your square around. Originally, this worked a bit different to Scratch. So in Scratch, and I think some other ones, you draw a rectangle, and then if you draw something over somewhere else, it locks that rectangle in place. And at the moment, this rectangle works that way. I kind of don't want it to do that. You should be able to, I haven't added the option, so you can paste it in one place and then move the exact same shape to another place, and keep drawing it, and then you can rotate it a little bit and go around in a circle. this is going to be a very much an ongoing process to get it just right. You may notice that the corners, they don't change from being on the corner of the shape. That's interesting, it doesn't line up there. Which, oh my goodness, they're getting, they're out by a few pixels there. Which is something I really wanted. I didn't want the corners to be over here, for example, so that when you rotate it around, the corners are always over there. I feel like it's slightly more intuitive. And you can grab the edges, and then you can wiggle the edges around, and then you can. So I've tried to avoid skewing. I don't know why it's come up like that. It used to work perfectly fine. Actually, I just realized something. There are actually two ways it draws rectangles. One way is it draws a rectangle by making it into a polygon and drawing it directly. And this is the one that's actually being scaled internally, which is always a pain and never goes quite the way you want. So this will be fixed. Don't worry about this. It'll be cool. But the ovals probably never will be perfect. Anyway, so you can scale. Ew, I'm going to draw another one. Okay, we'll draw another one. We'll change the color, and it won't change straight away unless I move this. So you can move them around. So I wanted to avoid actually revealing the mathematical operations behind this. Like, you know, in a typical drawing editor, you are aware of, you're sort of made aware of the skewing and the rotating and the translating and the scaling, because that's the way it operates. And I sort of, it's very subtle. I don't know if anyone will pay any attention to this, but we'll do an oval. Maybe the oval, you won't, with an oval you won't see the mess so much. Hold on, we can actually change. All right. So when you go to, that one's supposed to be a shape with that's supposed to be outline, and you can change the stroke. So you can do all the standard options. And we'll do pixel art. And you can see it doesn't automatically update at the moment. Don't worry, that will change. The one thing I didn't want to do too much on this, because I want to do regular updates on this project and for people. And I thought, well, if I go too much and finish the graphic stuff off, then I won't guarantee that I have something every week to show off or something like that. So I'll just leave the rest of the editor things hidden away, and then there'll be kind of easy adds. But again, you can do this. It's a pain to actually skew ovals, I'm going to say, because they go weird. Like, it's hard to get. I don't know. The maths are going to be hard for that one. And now it doesn't work. That's just charming. Again, yeah, there's issues. Lines, on the other hand, work fine-ish. Now it doesn't draw it at all. I wonder why that's happened. Well, anyway, we'll come back to that later on. That's not the important thing. The editor is always going to be a bit rough around the edges, but we'll get there in the end. So I will have an SVG editor, but I've decided there won't be two separate editors like there are in Scratch. So by SVG I mean a vector-based editor, which is I'm gonna honestly say will be much easier and less stress, I think, than the bitmap editor. It's just a pain to get. Like, there's just so many little quirky things that just take a lot of time to work out. But I'm going to just add that in. So I'll add layer support so that one layer can be a vector layer, and then you can have a raster layer underneath it and that kind of thing. So a sprite that's by definition a vector sprite will just be a single layer of vector stuff, and a raster sprite will come up as a single layer, and then you can add those things on. It does have weirdly shaped icons for undo and redo, so which I suspect are not going to work for some reason because I've crashed it somewhere. I'm going to can we just come back? We'll just come back to the sprite, and maybe now we can do. This is an interesting error. I might actually, you know what I'm going to do? I'm just going to restart this. Discard current, because it's gone a bit weird. new app project. Just do exactly what we do. Library. And we'll choose good old Anna Hip Hop. I think she's a sprite, so like a raster image, so we won't have to worry about changing things around. So again, yeah, what was I going to say? So that's basically the editor. It will do lots of cool things, and it will work well. So there's a few other things to go over. So these are all the things. You can drag them around and rearrange them. The cut and paste don't currently work at the moment. We'll come back to colliders in a bit, and we can export the image as we want. And it does have these things called like variables and a label, which are slightly more complicated than in Scratch, but we'll come back to that. So that's roughly the idea. You can declare, the one thing, we'll go back for this script. I don't know what that sound is, if that's on the thing. That's my neighbors. Okay, so a few other things. We'll just go through. We can do a flag. So this is a flag block. So these are the same blocks that you get in Scratch. But you could also have a variable. So I've tried by default. This is going to look a lot like Java. In the end, I wanted to have a C-like, which is what I call these sort of languages with the brackets and that kind of stuff, and a Python-like language that you can swap between if you want different scripts, depending on what you want to teach. So at the moment, it looks a lot like Java. So I can go int x equals 4. I can even, in fact, do things you can't do in Scratch, like I can go print x is 4. Right, and we'll run that. It doesn't come up with this. So I have to go, what is it doing? X is 4. Right, so it prints things on the screen. So you have print. Ask and say don't quite work the way that you think. They do work in the internal editor, but they don't have speech bubbles, but I'm not going to go over that at the moment. So you can declare variables, and it follows a Scratch. So they have to be, at the moment, they kind of have to be global variables. You don't have local variables, except that you do have global variables. And this will lead on to, before we go into that, we've got a few other things. So you do have while loops. You can do while loops. It does say it is typed. So I like typed languages. So this language has started from being typed, but I think you can write any or something. We'll see what actually you can write, because I'm going to import some Scratch projects soon, and we'll see what it comes up with. Again, this is a huge project. There is so much going on in this project that I'm not always remembering everything that I've done. But you can definitely do int. But you can also do local ones. So you could say int y equals 3 and y plus 2. So when I say, what did I write 4? I shouldn't have written x. That's not very exciting. We're going to write x plus y. One more thing. Okay, people are going to be like, you put a semicolon on the end. This is a modern language. Well, you don't need the semicolons, all right? I just write semicolons because I'm used to it. So we'll see what happens. And it says x plus y is 7. I'm putting... I've been programming in Java for so long that it makes me nervous not to have semicolons. I will point out that the semicolons are not handled... just looking something off there. The way this actually works is the parser is... my previous interest before this, and current, one of my interests is programming language design and compiler design and things like this, and parser design and parser generators. So the parser is quite advanced. It isn't doing what you see in other languages. So in other languages that don't have semicolons, they do that by inserting the semicolons for you. So I think they go through and they do a pre-pass, and then they add in semicolons that is then passed on to the compiler. This doesn't actually do that. You don't need to do that. So you can write things that you might not be able to get away with in other languages, like doing that. That still compiles fine, and in fact you can write like a whole mess of weird looking code and it's not going to get confused. The actual thing, what's going on, so that's my semicolon rant. I know that people will bring that up. So I do know that so I wrote the tool that actually is generating the parsers here. So it's a packrack based parser generator that I wrote years ago, but it's quite clever. It does left recursion and all that kind of neat stuff. And it's also perfectly capable of doing white space sensitive languages like Python. So that's not going to be a problem when the time comes. Though I like curly bracket languages. So yeah, you can do all the basic things. You can have variables. I'm going to have to quickly go over what's really going on though when you compile it. So when I run it, so this is a compiled language, but it compiles things pretty fast. So it's not like Scratch where you just click go and it interprets the language, and there you go. But in this case, it compiles it, but it also isn't just compiling it. It's compiling and running, and then it's running a generation pass, which is basically a separate execution of the program, which is then generating the code that is the final result, which is run in the internal virtual machine, which is running here, which isn't doing anything. This is I'm going to have a separate video on what's actually going on here, but in actual fact, there are no variables in the final result of this thing. All that is being outputted for the virtual machine is x plus y is colon. It may even in fact not be doing a concatenation. It might just be putting the 7 there. It already knows what the answer is. And this is why you can have local variables even though it doesn't actually currently support local variables, because this local variable works in the generation phase, but not internally. There are two types of variables. There are application variables, which are the variables that you see in the final product, and then there are macro variables, which are done in the macro generation sort of stage. But ultimately, it will have local variables, proper ones, in every single phase. The thing is, I built this specifically to take Scratch projects, and as you will see, to output Scratch projects. So I probably should show that next. Except something's gone wrong. Nothing's gone wrong. So we can go to the exporters. And we can add an exporter. So there are two types of exporters at the moment. There's Scratch2, so it can generate a Scratch2 file, and it can generate a web-based application file. So we're gonna have to do something a bit more fancy though. We're gonna have to say. So if we do say, it will say down the bottom. So now you've got down the bottom. This is how it says saying. I didn't want to do spend too much time on the speech bubble stuff. At some point I will do speech bubble stuff, and then you can customize the speech bubbles in way more than you can in Scratch. But they don't really interest me because I think more advanced, that's to be blunt, this is a kiddies thing. It's not a big person's programming thing. So it's not really high on my agenda of things that I want to put in. You can ask though, and it will put it down here. So you can see here it says Anna Hip Hop says x plus y is 7. So we're going to create an exporter. We've got Scratch2. I feel like I should do this slightly off screen in case it's going to come up. Hold on, I'm going to move it off screen just in case. I don't want to reveal anything about my computer. So I'm just going to create a folder. Anna, you can't see me doing this, but you're just going to have to trust me that this works. Alright, so, well, you can kind of see that I have a partition called bunnies. So we've got this, and it's going to export to a folder, and then I can't read what these things say. Then we can just run the exporter. and it will say export successful. And then we could actually go back to Scratch. So here's Scratch. I'm going to load a disk thing from the disk and not show you what the folder is. Well, I will show you a little bit actually. There's no point being completely silly about it. Where did I actually store it there? Hold on. Bunnies. Dun, 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 dun. Okay. Alright, well I can show you. Okay, we're going to bring this back over here. Here it is. This is the file it's created, ANA-SB2, and then we'll open it up. Replace, yes, sure thing. Alright, load it in. Oh my goodness, it didn't compile it the way that I wanted it to. So it used to do that, so I'm going to have to investigate this. Again, language features, it changes. It should have actually just put that all into 7. As you can see though, there are no variables. It already knows what X is, and it knows what Y is. So I can say repeat 1. X equals 5, right? And save. Oh, there we go, revealing things. So we're on the exporters again, or in exporters, and then we'll go back to here, and then we'll load it back up again, load from my computer. Yes. And now you can see it's created the variable X, and it's done all of that code. And that's simply because, well, I've actually used it. Like in this case here, before I did this, X was never actually changed in the code. So there wasn't any point putting that variable in. It's just going to store the actual value of X. And it's quite smart about this. It will work out in the cases where it's not needed and stuff. You can force it to actually be there. So I could say app int, and then it will always be there regardless. So anyway, you've got that. So you can do a lot of things. You can do all the other bits and pieces. If you want to do messages, you have to go like message cat, and then you have to go say on cat print cat. And then we'll go back to the stage, and we'll go flag broadcast cat. And then, oh. Alright, and then you can see that Ana Hip Hop has in fact said cat because they've received that broadcast. If you want to broadcast and wait, I think the current notation is broadcast like that. And that won't continue until all the cats have done. So all the basic Scratch things work, and it will output to an HTML document as well, which we'll show in a little bit. So we've done the sprite layout. So there are lots of other extra exciting things in this project. Like there's a huge number of things. Other than the fact that you can take your Scratch 3. Oh yeah, the one thing. Well, we'll do one more thing. I'm gonna again take it off the screen, so I don't want to show. But I'm going to go open file. You can just have to trust me here. And yeah, I probably should have. Actually, no. We'll just go down, and we'll choose. Okay, I'm just going to go. This guy, Karen. I'm just going to go into the recent. Where is it? Recent. We'll go down to Griff Patch, a Griff Patch thing. So this is being loaded in originally. So this is like Griff Patch is like I think it's how you say his name. It's like a big, Scratch personality who makes lots of good tutorials, teaches you how to make games. So this is one of his. One thing that's missing is the audio. So I haven't done the sound. That was going to be a thing for later on. That won't take very long. but everything else. So you can see that this is imported from a Scratch project. Now, one thing that's going to come up, and of course the difference in Scratch, you can just zoom in and out and move things around, which is kind of pointless. But you can go really in there. Look at them. You can see the blurring. This is the Java FX zooming in, and it's hard. You can't get rid of that, and it doesn't work very well for pixel art. Anyway, so we're going to come over here. You'll find that I don't know if I can actually jump on top of him. The reason for this, we'll come back to that in a second. So we'll go through, and these are all the imported objects, and now we can suddenly see it's gone in through here. It's called them Scratch. This is because I forgot to change. I don't know why it's done. Why did I not get around to... So originally it said Scratch, and then I changed. I thought, well, if it's going to be built in, I can't call it Scratch because that's a bit too on the nose. So I'll call them apps. So for some reason, the importer still uses the Scratch keyword. And if you do that, you don't actually specify the type of it. It doesn't care. This is anything type. Originally, I tried to be super smart and get it to work out the type of every variable. Like if you'd given it a 4, it would have said this was an int. If you'd given it like 15.9999, it would have said, oh, that's a floating point number or something, or a double, because that's what it's doing. So again, this was originally meant to be the test language, but so it's very Java centric. I don't know why it's done this. It's really interesting how... Maybe this is because I accidentally changed... I think actually the reason is because I changed it to say that at the previous point. This is not actually importing it directly from Scratch. It's a previously imported project. But trust me, it does work. You can import Scratch 2 and you can import Scratch 3. So this was a Scratch 3 project. You would be able to export Scratch 3. The major problem is that when I made this, I was all like... I was just going to check that I'm actually still doing this. I'm still recording. Yeah. So when I originally did this, the idea was you were going to export the project to Scratch, and then you'll be able to upload it to the Scratch website, and you'll be able to continue using the Scratch ecosystem. And because I originally thought about that, it doesn't have many features that you can't do in Scratch. So you can do things like printing to the output, which you can't do in Scratch. Those things just get ignored when you output it to Scratch. The problem is, of course, is that I finally got around to checking the terms and conditions of using the Scratch website, and you're not allowed to upload Scratch files that are not built by Scratch. So this project uses absolutely no code at all from Scratch. I haven't looked at any of the code. I've just reverse engineered and gone through and worked out how everything works by looking at the files and all that kind of stuff. So I've left in the Scratch 2 stuff. I'll put in a disclaimer, and I probably will put in a Scratch 3 at some point, because I guess the point is there are other Scratch adjacent websites, like I'm thinking of Turbo, whatever it's called. The other ones that you can use. So you could still use that as the ecosystem. But for now, I'm going to pretend you don't do that. And the main targets will be, at the moment, will be HTML and probably a standalone Java thing, and probably Android. And I'll talk about a few other things later on. As you can see, this is how it imports the code. So a lot of the stuff that it's doing here is not necessarily needed for your own code. It's just simply thrown in there because Scratch encourages, in a way, terrible programming, as far as I'm concerned. Well, not terrible programming, but to get the best out of Scratch, you've got to hack things, and sometimes it's not always obvious. Like when it's importing, I don't really know if it's from the it doesn't know if it's 24 or if it's 2 or something like this. And I had all these problems with trying to be too smart. So when it says sloppy at the top, this just says everything after it. Just be very be loose with the interpretations of things. Because that's how Scratch things are written. So when you import things, it always uses this. So I've tried to treat lists like arrays in other languages, which I'm going to change slightly, So I'm going to have proper arrays in this language, and lists will be slightly separate, but they will still use a square bracket if you want to access elements. So if you've seen a normal language, you often use square brackets to reference an element in an array, which is what's happening in this line here. The reason it's double is that means reference something in this array, but don't worry if you get it in the wrong position, if this index isn't a valid one. So if you do it without that, it will actually complain if you try to read an element that isn't actually in the. So if you try to read something at index -25, it will say out of bounds and not be very happy. Where if you do this, it will probably just say a warning and ignore it. That's just because it happens so much. Everybody's like, I want to be able to import, a reasonable amount of code, but most of the time, again, this is you would type normally string. So this is how it imports blocks. Block star just means the turbo block or run without update. I will have to talk about the run without update because I made a boo-boo. These are code that I've written in previous points. Again, you write this. You don't have to write this. You can just write fxdx. That just means you're referring to the fxdx of the sprite, not of the stage. In your normal code, you wouldn't need to write this. Again, it's writing all this in because it's imported it, and it wants to make sure that everything is understood. The track stuff is debugging code. This lets you create, you can track this variable, and it will make a little graph for you and all these kind of things. So like I said, there is so much extra stuff going on in the code. So this is it's telling you here that these are runtime errors over here, by the way. It's telling you, I can't remember what I was going to say. Well, anyway, there's just a lot of extra features. I don't know if I'm going to get through all of them today, but we'll keep going. So another thing is, well, okay, you've got a terrible editor, but it does list the editors here, and then you can go. So at some point when you were doing the runtime stuff, this thing set this was not set up properly, and so it said, I don't know what this costume is. So there's a bug. So it's better than Scratch. It will tell you more errors as you go along. But because you've compiled it, you actually now can go through. So these are all the flag blocks. There's a flag block in Mario. So it takes you directly to there. There's one in enemy. That's what it looks like. There's message blocks. So if you click on level stop, you can find where you defined it. You can find all the broadcasts where they came from. You can find all the actual blocks and jump to them directly. You can look at the stage. The stage will tell you what variables there are. You can look at what things. There's the declaration of grid width in the stage. You can click on that. You can find all the different places it's being used. So when the editor actually is, much better, then it will have, lots of all your standard tools like intelligent things, code sense. That's what the word I'm looking for there, and completion and all that kind of stuff. They're all basically there. Like I could add in some completion tools, but it's just because you're struggling because the editor is rubbish. And you can't drag and drop. Another thing is you can't drag and drop things in because the built-in editor doesn't appear to let me actually know what cursor position I drag and drop stuff. So we drag and drop things, and I think it just puts it at the end of the file, so it's not that useful. So anyway, jumping all over the show here. So you've got lots of things. You can do search. So I could go. That's a command key. And I can search for Mario. We can ignore the case, and then you'll find, in a terribly badly formatted way, all the instances of the word Mario. One of the things I haven't changed to a more legible format. But anyway, so you've got lots of sort of tools hidden away that you can use. So you've got that. Now, there's a few other things. I don't know if I should get a new project. We'll just go to it. We'll go to, there's my recent. That's going to give it away if I go to the scene test. We'll go to, discard current. Except it hasn't discarded it. It's decided to keep the previous project. So that project. So close project. Wait a minute. Discard. So it isn't very good at giving, at the moment, because the old code didn't set up the project name very well. I'm going to close all the projects. Then that menu doesn't work very well because it shows you the project name. Why does it still do that? Open file. Open recent. Okay, let's just pick, I don't know, that one. Alright, that one's not going to be found. Alright, we'll pick this one. Okay, so imported, all nice. So we have a sprite, which is a thing, and there's two of them. The background, what is this? What is going on here? Right, errors. Alright, I don't know what's going on. Why are there two? What's that one? How did they get the start frame? Oh, I remember this one. This is a markup. Okay, we will close that one. That was a markup from. Again, it forgets to get rid of that, so that's all right. I'm going to go library. Have an airplane. So we have an airplane. We're going to have to change the background. We'll go library, and we'll do baseball field. And then we'll go back to default layout, change the start frame. And that, of course, doesn't work. Charming. I'm going to get rid of that one. Let's go away. So another thing, you delete things in this weird way where you click on it and then it has a comeback. So it hasn't deleted it from the project, it's just marked it for deletion. It won't actually delete until you save the project. In that case, the saved project will not have that in there anymore. But you can always bring it back at any point that you want. So hopefully now. No. Alright, it doesn't matter. So we'll go down to here. We have scenes. So another feature that's not in original Scratch is this idea of scenes. So Scratch is not very useful. It's a bit of a pain if you want to have different scenes to go to or different sections of your game or app or whatever. So this sort of is now structured around the idea of focusing on scenes. So we're going to have a new scene, and now we've got that scene here. And this is what scene looks like. We can change the... There we go. I don't know why that doesn't look good. Why are there errors? Right, what are the errors? Scripts. Oh, this is not going well. There's something gone. Hold on, I'm just checking through the debug output here. Why does it not actually work? Ooh, I see. I've mucked up a little bit in the code. Hold on, let's just try one more time. Look, I'm not okay. I admit it. There's a few things that I didn't check before I did this. Discard current. Oh my gosh. You know what I'm going to do? I'm just going to restart the app. I mean, this is good. This is beta testing, right? We're beta testing. That's Miffy. All right, so, okay. Do this one more time. And this time we're going to choose airplane again. And we're going to choose Anna again. And then we're going to go, and we're going to go new scene. And then we're going to go to scene number 1. So you can change the background. I'll fix that later on. Anyway, so we have these scenes. All right. And now we can add our airplane to our scene. But then we can add another airplane to our scene. and then we'll add a hip hop on her. She can be there. Let's put it in the wrong place. That's fine. And we have all these scenes, but these annoying little dots which are debugging information, so just ignore those. I think you can turn those off, or you can add them on. So that used to work. New scene. That was the old way of doing things. Again, some of these things stopped working when I added the multiple project functionality. So you can do this, and then in your stage, what did I call this scene? All right, the variable. We have to give it a variable name. Scene 1, which doesn't work. I think this has got to the point where I honestly have to restart the video. Well, I'm not going to restart the video. I have to fix those bugs. That will make an exciting next follow-up video where I fix the bug where you can actually do the most important feature. Why can't I change the variable name? What's it saying in the debug? It's not giving me anything useful. Must use only. So apparently I can use nothing. Wait, but I can't use variable. Oh my goodness, what have I done? Moo. Must use only alphabet. Moo. Okay. Well, you need that because what you would do is then in here you could do something like flag go. Let's just pretend we call it scene 1. And then it would jump to scene 1, and scene 1 would look like that. So it would set everything up for you so that everything is in the place where you want it. And it will clone the sprites so they all appear at the right place. But the most important thing about this, trust me, this all used to work sweet. So it will work again. So ignore the fact that it's missing an important function. Or it decides that I can't name the variable properly. So the most important thing here is action. So what I really want in this project is I don't want it to be just a tool for people to do coding with. I want it to be a tool to make like other toolkits for other people to make things. So maybe you can make a game maker out of it. So this is sort of like a step towards that, and this is the idea of actions. So we can create an action. This is where I'm gonna muck up because I can't remember the syntax. Action spin. I'm going to say an amount. Repeat amount. Turn left 1. All right, and then we'll just compile it just to check if that works. Okay, I got that right. I think, did I go spin? Does that work? Yeah, that works. Okay, that's the syntax. So I want it to look like fancy. So anyway, I can go back to here, and then I can go to my actions, and then I can go add event, and then I can say when clicked, update, then I can add an action, and there's only one. Spin the amount. And move this around again. I was supposed to fix all this up because I don't like the way this looks. It looks terrible. But I've run out of energy. I need to get this published and shown to people, so it's not going to look fancy just yet. And you can spin, and then that action, when you click on that person in that scene or that sprite, it will do what you said. So this is kind of like in construct 2, construct 3. You have behaviors and actions and event. You have an event sheet and all of that. It's kind of like being able to add that functionality. But this is the first step where you'd be able to import libraries of actions, and then you'd be able to do a lot of the heavy lifting. So somebody else writes cool libraries to do things, and then you wouldn't have to do any coding. So it's hidden away there. But I want to do a lot of extra bits like that. So, oh god, I've done it again. All right, do the same thing. There are different things. These are the only sort of things that start events at the moment. So either start actions, so either when the scene starts, they automatically do the action, or when they're clicked. But also I'll have when the scene is ending. I think that's an important one. Plus a few other things like when you press a key and all that. So you do have key pressed events and all that kind of stuff, but they're not here. And you can add multiple actions. If you add multiple actions to the single event, then they will get done sequentially. So this will do that first action, spin 10, and then it will do the next action. So you could have another spin, there's only one action, 20, which I can't show you because I can't go to the scene, but it will work. That will be a cool follow-up video where I fix all the errors and show you that they actually work. But of course, if this thing doesn't finish, this one won't actually get done. But you can have multiple events. Say when clicked, then they'll do them concurrently at the same time. So one of the big things I like about Scratch, well, I hated at first, was the sort of implicit multitasking that it has, or the implicit cooperative multitasking that goes on in the background, which is terrible because it encourages people to write things like, forever. Whatever, you can't turn left as a stage, but next background, next frame. I think it's called next frame. I think next frame works. So you can do that, and of course the problem with this is that you wouldn't do this in any normal programming language because that would just tie up the CPU for too long, and it's got this sort of weird thing, and it encourages you to do bad things. But I've sort of grown used to the idea that maybe you could use this or something cool. So that's part of what's going on in this project as well, is to produce something that lets you use that same kind of multitasking environment of Scratch, but for more powerful programming language features. You can see here that there's actually net functions. They don't show up at the moment because I forgot what they are. I did actually write networking code. At the moment, I'm not going to say that it works because it's on an old version of the internal virtual machine that runs the Scratch projects. And it was designed for making sort of local area multiplayer games, so I play Nintendo DS sort of games and that kind of stuff, and you can do that sort of quick. Well, you can do it on Switch as well, where you can have sort of quick multiplayer within people standing next to you kind of thing. So it wasn't designed and isn't designed and won't be designed for large scale networking at the moment. Anyway, we'll forget about that for now. So it does have this cool idea of scenes. So you can have multiple scenes and then you can jump between them all, and it handles all the things. And the important thing is this feature is not in Scratch, but it will actually compile this out and build all the code to manage it. But because I can't show that exact feature, you just have to trust me on this. You can also supposedly add stage actions as well. So one of the things is I want to make it super easy for you to do transitions between scenes. So you should be able to fade in and fade out. You should be able to, well, you won't off the bat be able to do that, but you'll be able to write an action to do that very easily. So you should be able to say stage action on scene start, fade in, on scene ending, fade out kind of thing. So I think those are the major things of the basic thing. So, we are missing one really important thing, and we're going to have to go back to close all. Discard current. We're going to have to go back. I should have fixed that little problem. We're going to have to go back to let's do the laser tag thing. We can do the laser tag. So one thing about laser tag is, now it's going real slow. You can see that it flickers a lot. It goes fine once it gets going. There are some options. You can make this run perfectly fine if you go to the prefs. So there's lots of options in the preferences. One of them is this max thing. So if I make that 20, then when I run it, it should be fine. There you go. It's just using more processor time. So I made a mistake because I didn't really take the run without screen update option on the blocks to be literal, which is a bit silly. So when you say run without update in this thing, it just means run turbo. I have to do a completely separate video on the multitasking infrastructure and how things work and what really happens when you do certain things. And because I didn't do that screen update, you get the flickering effect if it doesn't manage to do all the drawing in one frame. Then it doesn't pause the updating of the frame until it's finished doing the drawing, like it would in Scratch. So there's a couple of other 3D games, which I'll show another day, where there's a Sega Virtual Rally, or is that one of them that is? There's like a bunch of 3D racing games and stuff. They work, but they flicker because it isn't managing to do everything in one frame. I should probably export this. Well, we're gonna go back. So I will fix that. That's a really easy fix, but I only realized it's like after it's like, oh, maybe I should have actually taken that to heart a bit better. So as you can see, it does all that. That's a project that relies a lot on the uses of pen stuff, and so that all works fine. Now I did in this project here when I ran it. You may notice that Mario doesn't actually die or it doesn't actually, what are they called? Goombas. It doesn't actually squash them. That's because, so one majorly important difference between this and Scratch is that it doesn't, in Scratch you can say if a sprite is touching another sprite or if a sprite is touching a color, and it does that very precisely. It's like pixel by pixel checks, and that's a pain for me to code, and I don't want to do it, and I don't think you should do it. I think that makes for terrible games, and I think it makes for terrible collisions, because you never wanted to have on a pixel by pixel. No thing is fun if it's that accurate. So what you have to do in this case here, and unfortunately this is a bit dodge, and I will explain why I haven't updated it. You have to go to the colliders, and then you can add a circle. Very big circle. We'll have to make it smaller. So we can go down, and so we can add. At the moment there are only two types of colliding things. The box doesn't quite work. Again, I did these colliders because I really wanted it to be translatable to Scratch. So I didn't want to have a complicated collider that would be too hard to translate and back into Scratch code. Since I'm going to give up on the idea, then there'll be more advanced. There'll be like more advanced collision boxes. So you'll have boxes and you'll have general polygons and things like that at some point. You also have touch points. What does it use default box? Oh, I think it was supposed to work these things out for you, but it doesn't at the moment. So the major problem is, which one did I give it to? Oh. Right, that's going to be a pain. I don't know where I put. Again, I changed the code. Is that one with the colliders on it? No. Didn't I just add a... Well, it's decided not to work at all. So again, yeah, it worked before and it doesn't work now. But you needed to add the colliders, and if you added the colliders to everything, then that would actually work fine. The problem is you had to go through and add them one by one, which is a pain. The reason I haven't exactly changed it is that I want to change the way that I do. So at the moment I'm following what Scratch does, and Scratch just has a bunch of costumes, but that's a rubbish way of doing things. So what I will have, the next thing is that you'll be able to define separate from the sprites animations. So in which case you might have Mario walk being a particular animation. So a 4-frame animation is Mario walk, and when I do that, I'm going to add in a collider for all of the frames. I didn't want to do it for the costumes because I feel like, well, these are quite different, so they're all going to have different colliders. So I haven't gotten around to doing that because I thought, well, I'll just wait till I've added the animation things. But I probably will, when I fix up whatever's gone wrong here, make it so you can just copy and paste to all of them in one go. because it is a pain. It is. I admit it. That's a poorly thought out part of this. The hit points. So you can actually add points, which I can't show you because it's decided not to. What have I got? There we go. They are there. It's just things have got confused. So we can shrink that down. Where's my point gone? Oh, it's in the middle of the collider. Alright, so we'll move that there. So you can have hit points, which are little tiny things. So you don't have to, strictly speaking, you can have more closely related to pixel perfect collisions if you want. So a hit point is only used to determine if you've collided with something, so, or touch point. So if the touch point in this is touching the collider on another sprite, that's a collision. So this means you can do more accurate collisions, even if you're colliding with just a circle. But the main point of that was, I was going to allow, well, you know, am I touching a color on the background? So I think that might be useful for some games. And so you will define a bunch of important touch points. And so when you say, is the sprite touching a color, it's only checking at those particular points. And so there's a much lower, you know, for me, like the whole idea of doing a pixel by pixel comparison between multiple sprites is just hugely inefficient. And like I suspect that when the Scratch team went to Scratch 3, the reason it took a bit of time was they had to come up and create that feature again from Scratch 2, which was probably built into like Flash or whatever they used. And that was a bit of a pain to do with modern like web stuff. So I'm not going to bother because I think it's a terrible idea. But there will be like circles and boxes and touch points and much better interface for that kind of stuff. Again, you can delete things like that. So later on, I realized afterwards, it's like I should have just gone with the trash can idea that is the standard way. I don't know why I didn't think of doing it. So I've got this sort of cross thing, and then you can bring it back if you want to bring it back. But unfortunately it forgets that you can't just stick to collide. You know, if you change sprites, it forgets what you were actually editing, and this doesn't change back again. So what was I going to say? I've forgotten. Yeah, so I was going to. So that will come back. I will actually add the trash. So you'll be able to drag things to the trash, and then you can get them back. The reason that I did this is that undo and redo. Undo and redo, like it gets confusing because there's so many things you can undo and redo, and I don't want the options. Like it felt like I can't just undo or delete. I had to use a different sort of method. So the trash can would have been the smarter way of doing it. But the thing is, the fundamental underlying storage, the way that it is knowing whether or not something is deleted or to be deleted, translates perfectly across to how you would do a trash can. Dragging to a trash can is going to be exactly the same option as this, except it's not going to show up in the list anymore. So anyway, so that's the main. I'm sure there's a bunch of things. So there's a lot going along under the hood. Like there's so much going on under the hood. But that's for another videos. But if you've been watching this, you may have noticed that there's a few other options going on. So the use of the word sprite is an old term in the land of computers and computer games, and I think the computer that really popularized, it didn't create the term, but popularized the word sprite would have been the Commodore 64. And so because I'm quite keen on programming and compiler design and all the sort of stages, I really want something. So this does compile to HTML in a very messy way, which I'm not going to show you. Like I'm not going to show you the code that it generates at the moment because I want to change that dramatically. But that's not going to be too hard. But I wanted to do like more low-level stuff. So the first thing I've done is we can go new C64 project. So now we have a new C64 project. And so basically this is Scratch for the C64. So I was going to say that this Commodore 64 is the computer where I think, when I think of sprites, then I think of a Commodore 64. I think the first use of sprites would have been probably on, I think, this TI 99-4A that I know of. But the Commodore 64 was like well known for its sprite graphics. So I feel it's kind of right that you should be able to do this for the Commodore 64. So in this case here, it's not running, it's compiling it directly for code to run on a Commodore 64. It's very limited at the moment. There are no actual sprites. But a lot of the programming language features are there. So except you have to be a bit more low level. So I have to say byte x. You have to say it's a byte, not an int, because it doesn't do ints at the moment. But we can say like that, and then we can say print x is. I think I can do it like that too. X is. Stop editing the thing. All right, and now, because this is a Commodore 64 project, you might be like, oh, so it's going to compile it, and then I have to go and load up my Commodore 64 emulator just to try it out. It's going to be a pain. Well, no, it's the type byte. Oh, that's right. It's not byte. It's ubyte for unsigned byte. Oh, gosh. So there we go. Except this printed it in... how do I do this? Print is. Print X's. So the Commodore 64s, they have a very funny built-in, like this is just outputting it directly, and it doesn't do ASCII properly. So on the default character set, there are no lowercase letters, and everything has to be uppercase. So that's why you saw the mess before. So it's just run it, compiled it, and outputted it. Again, you can do local variables, so it doesn't support it, and you can do things that aren't supported on the Commodore 64. So at the moment, we have to go back a few steps here. There are only two types of variables that you can do at the moment, and those are unsigned bytes and unsigned ints. So you could go uint. But you can do at least a couple of the loops. You can do repeat 5. And then we can do x equals x plus 1. It doesn't get the, oh my gosh, it doesn't get the reason it's overwritten things is because underlying issues. It's nothing serious, don't worry. But anyway, this is just a proof of concept. This is not meant to be the final product. So the final product, you will be able to edit Commodore 64 sprites and make Commodore 64 sounds and build Commodore 64 screens and do all of that kind of stuff. What I really wanted to do is just test the underlying, but build the basic concept stuff. So I wanted to have all the features of Scratch. So you've got this kind of stuff. Then I can go flag, so I can have two flags, and then we can go repeat 6, and we can go print what is up, and then we can run that, and I did it again. So yeah, to pretend that says what is up. Again, it only does uppercase letters, and the lowercase get turned into funny graphics characters. But as you can see, it is multitasking it, and it's alternating between those two things. So the whole Scratch multitasking works. So the important thing is we can do a few other things. We can go, we'll do another flag. We'll go flag, and we will do poke 532801 or 2. Okay, so this is this is where you're directly addressing a memory location in the Commodore 64, and this one is the background color. So if I do that, it will very briefly flash red. So this line at the bottom is actually an interrupt. It's actually going here and it's setting the colors. This is all debug stuff. So if you want it to You have to do this forever. So we'll do it forever. I hope I actually implemented forever. I can't remember if I have. I think I have. Oh gosh. And then, so now it's fighting against the urge to. So right down here, it's been converted to black, the background, and it's fighting against here. But the good thing about this is you can kind of see how long it takes to switch between tasks. So if I go, we're going to have another one. They're going to fight this out. And they're going to go, 3280, and that's going to make 3. So we've got 2 different processes, and they're running, and they're trying to change the border color. And you can see these lines represent the time taken. So basically, it's changing things. It's a bit hard to tell how fast it's doing this, because I wrote this. This is a Commodore 64 emulator I wrote a long time ago, which is the reason I started with a Commodore 64 for other direct targets, is because I've already written the editor. I already know it I know how a Commodore 64 works very well. It's quite easy for me to work with. So the timing isn't perfect in this, so it might be a bit slower or faster, but it is in fact changing threads quite fast. So you can do that, and you can do blocks. So I can say block do what's up, and then we can go down here, we can copy that one, copy and paste. And I can say do what's up. Same thing happens. Oh, I should have changed. That. All right. So blocks work. Everything runs at turbo speed on the Commodore 64. So there is no point making it a turbo block at the moment. Though this could change later on. Though because it's not actually Scratch, I might do things differently. So you can do messages. So again, messages work. You can say message what, and you can say on what, and then this one could be broadcast what. Same deal, everything works fine. So yeah, there is one other thing though, which is if you want to go to the next frame, you can do things not turbo speed. So what I will do is I'll write some code. I'm going to go poke 32 for 8 to be 100, and poke 3249 to be 100, and then I'm going to poke 32. You can do what's the word? Peek. You can peek a memory location as well. That works. So there's only a few implemented commands, and you can test whether or not the joystick is up or down or left and right. So if I do that and I run it, there's a little sprite. That's what a sprite is. So I click on this. There's a sprite. It just sits over the top. It's a hardware feature if you've never seen a Commodore 64 work before. And that sprite will just sit there no matter what. I don't know. Look at that. There's a mistake in my. Well, actually, that makes sense. I'm surprised actually the interrupt's still working. I must have written it mostly correct. So anyway, there's a sprite there, and so we can then go poke 3, 2, 4, 8, 100. Well, actually, 100 plus x. For Oh yeah, the thing about the semicolons is that I'm not entirely sure that it always works properly with you don't put the semicolons in, because I always put the semicolons in. I will do a video on how the parsing works and why there may be a case where it doesn't work, but it will just do something you don't expect. So because I haven't tried it too much, I don't know. X equals x plus 1. X plus equals 1 should work, but I haven't tested it, so I'm not gonna try it. So if I run it, you can see, oh, look how fast it goes. It's just zooming along, which is not any good. So but you could do, so at the moment the keyword is yield, which is I feel like this should be what the keyword is, but yield is used in other languages for generator functions, and I kind of like, wow, I don't want to mislead people, and so I have to not use this word. So it's probably going to be next frame or next or pass or something like this, but this just puts it off until the next frame. So this works in the Scratch code as well. It will yield until the next frame or update, and you can do that in the middle of a turbo thing. I think it gets compiled into Scratch as wait 0, which doesn't work quite exactly the same. But now if I do this, it will yield to the next frame, and then you get the sprite moving fine. And of course you can run this multiple times and have different sprites being moved by things, and it all runs quite smoothly. So I don't know how well this is going to come up in the screen capture, but this is running 50 frames per second. It's not breaking a sweat or anything there. We can do something useful. So we can go poke flow 3. Actually, what we'll do is we'll do after the code 803 802. So we can use this to check the timing of how long it takes. So it can't be before the yield, and then run. So this black section at the bottom is how long it took to do that code, but most of that time is spent actually in the scheduler. It's going through and sorting out the change of stack and change of thread and all this kind of stuff. So there's not too much time to move a sprite around. So it should be quite a good tool for writing lots of things. Exceptionally, oh, that's right. That's a problem from the Commodore 64 emulator. So the other important thing with this is that as part of developing this, I also developed an assembler to compile to do the producing the machine language code the machine code that comes out of this. So it's compiling directly to machine code. There's no intermediate language or anything running in the background. So I wrote an assembler. So people will be like, oh, do you have to write everything? Do you have to do all of this? And it's like, yeah, well, I think people are right. I think there are better ways of doing lots of things, so I like to do that. So what I would have done originally is I would have written something to output code that I would have then sent off to a third-party assembler. So I would have been doing text generation, which is, I'm quite big on code generation tools. There's a lot of code generation tools going on under the hood for this project. But I did a different approach, and so I've written a assembler which is designed specifically for working with compilers of languages. So it's like a fully fledged programming language that lets you do lots of neat things, which is something I will talk about in another video, but it's very cool. So one last thing is this MPU project. We can discard it. It doesn't discard it. It just sits there. Fine. So what I would like to do is to do this with microprocessors. So then the other target. So going back to the Commodore 64, I will probably look to add other targets. So the computers that I am most familiar with would be a Commodore 64 and the Commodore Amiga, because I grew up with those computers and I know the assembly language very well. So that's a viable target for additional things. So an Amiga might come up for that, an Amiga and Atari ST. Other 6502 based computers like Atari, maybe Apple and things like that. Not Atari 2600s. That's never going to happen. And so then, there's a lot of scope for adding, some. I would really like to do the Nintendo Entertainment System, the NES, simply because you get all those cheap little Chinese game systems, and they're just running the NES on a chip. So there's all those things. So I kind of get the idea, like, well, I could write a tool. People could write silly rubbish games for those things. So they still sell them, and you can get some that take SD cards. So that could be a useful target for something that people could actually use to write games for their little handheld tool. But we'll have to see. I'm vaguely familiar with how an NES works, but I haven't written an emulator for it. So the emulator that I have written does do VIC-20 as well, so the VIC-20 is another target. If I was going to do... Oh, one more thing about the Commodore 64 is I haven't done floating point variables and all that kind of stuff. It isn't actually there anymore. Okay, there isn't here. Oh, no, it is there. I'm looking at it. What was I going to say? Yeah, it doesn't do floating point numbers, which seems very odd because I could just use the built-in floating point stuff, which I will do. But when I distribute this, I don't want to distribute the ROMs that go with the Commodore 64. So the built-in programming language and that kind of stuff. Because I don't really know who owns the copyright, and I know it's very easy to find. So at some point I'm going to add in... I kind of wanted to do the whole thing without using system code. It does use the system code to print things, but the variable stuff is all written code by me. So we'll have to see how that goes. So I don't know if people can tell me that, oh, definitely it's fine to distribute the ROMs, they'll go with the ROMs. Otherwise, what will happen is that you can add the ROMs into a directory later on and it will work fine. And if you don't, it will just use some mocked up code to do things. But I didn't want to do the floating point stuff straight away because I thought, well, I don't want to make too much work for myself. But anyway, it doesn't matter about that. So coming back here, I wanted to do this for a thing. So basically like your Arduino. So I've actually started writing an emulator for Arduinos, and I've got a good way through the adding AVR as a target to the assembler. I've also started doing it for PIC. I've got a whole bunch of these PIC 16 series things, like I've got like 500 or something, and I really want to use them, but PIC machine code is quite something. It's very, very basic. But it will be quite fun to give that a go. So the way that it will work is you'll have your script and you can do all the stuff, and you'll be able to... I can't remember how it works, but the idea is you'll go to your design, you'll be able to add in the named pins. So you could say, well, I'm going to have a thing, I'm going to call it LED and whatever, and then you're going to be able to design and plug in chips and run it on here. And see it working, and like you'll be able to have LEDs. Like I have to go into how I want it, but you also have multiple targets, so you can say, well, in your code you're never going to refer to an actual pin on the microcontroller. You're going to refer to a named version. So you might be saying this is LED 1, and then in your targets you'll add in like Arduino, and then you'll say on my Arduino. I'm going to attach LED 1 to pin number 12 or whatever, and so it will compile the code as though when you say LED 1 you mean pin 12, and so you can change that around for different targets, and it will compile that and produce the code for you that you can upload. So I'm quite excited about this. So this is something I've been wanting to do for a long time. So this will be very cool. And if I don't get much interest in this project and I can't really continue doing much else, I will just spend my time doing this, because hopefully there'll be more interest in this. And also it's the thing that I really want to get done. But at the moment you can't do anything with it. So a lot of the, just going back, all the Commodore, all the language features are here. This is using the same tool, so you can even though I said you can't do floating point numbers and stuff like that, you could say float double f equals 0.5 and print f is f. And hopefully that, well, I haven't actually tried this, but I'm hoping it works. I have to get rid of the close project. See, now it gives them correct names, so that's nice. Discard current. All right. It doesn't say the right message though. So you do that, and it will say 0.5. And again, that's because this isn't being compiled. This isn't getting to the compiler that compiles the Commodore 64 code. This has never even got that far. This is being taken care of in the generation phase. So it's just turned this into a string of 0.5. But you can do a whole bunch of things. So you can, int x equals y equals 3. I'm not going to go. Actually, you can do lots of really cool things, but I won't talk about it now. Anyway, so that's. I think that's most of the things that I wanted to talk about. There is a lot more going on in the background. But the one thing I want to finish this and say, well, I can't continue this at the moment because I'm basically out of money. I can't. I've put a lot of effort into this over the years, but I don't have the. I really need to sit down and be able to focus on this. And unfortunately, I don't know how much longer I can give too much time because I just can't afford to do it anymore. Like I will continue, but again, as I said, if I only have like once every so often to work on it, I'm just going to focus on the Arduino stuff. So what I really need, I mean, not just money, but I need people to actually care about. Like I haven't really shown anybody this project the entire time I've worked on it. So if you like this project, if you think it's really interesting, at the very least, like this video and subscribe to this channel, and like give a positive comment saying, something about this, so that I know people really want it. So if there is interest in this, then I will definitely try. And the idea is to fix up all the little odd bugs that you've just seen today, and change a few things about the language, and then publish that as not a very easy to use but accessible version that people can try out. And hopefully that would be by the end of the year. Hopefully by sometime in December, maybe 2 versions like that. And then once I've got everything roughly done, and I've added in the sound option because I really want to have the sound in there. It does acknowledge the sound commands, but it doesn't do anything with them. To chuck in the audio and make something that's basically usable with a terrible editor. And then make a proper installable version sometime in January next year would be like my time frame. Again, this is like, it depends. Like the other thing is, if you check in the links below, there should be a Patreon link. So if you want to support this, really the best thing you can do is to help out by signing up to my Patreon and giving me some money so that I can pay for food and everything else. And that I don't have to go off and find another job. Like I do have a job at the moment that's reasonably flexible, but it doesn't pay enough money, and times are tough, and I have to look around to feed things, and I'm running out of savings. So if you could do that, that would be really, really awesome. Or if you want to give a donation, please get in contact. There'll be an email address somewhere, I'm sure, or you could leave a message. And yes, so this isn't currently available to the public because obviously there's too many things that have to be fixed up. Oh, there's a few other things I forgot to mention. There's this command line here. It's called command. It's got the wrong, like it was meant to work kind of like the browser location thing, and you can go backwards and forwards. But over the years, this is gone between working fine and not working at all. At the moment it doesn't work, again because I changed it to have multiple projects. I changed it to be able to have multiple projects when I changed it to have Commodore 64 projects, and so it should actually say something along the, why can't I type? Oh, I've disabled it so you can't actually type in there anymore. But yeah, so you would be able to go to different, and you'd be able to bookmark things and then go to different parts. And also, because I want this to be used by kids, I do actually work with children, so I've got a lot of experience working with children, and I've done Code Club and stuff. So at some point, I would really like to try it out. In fact, I wanted to do a PhD on this and be focusing on actually testing things out with actual children in classrooms of children or teenagers, and seeing what things work, like running tests and seeing if they're being able to drag and drop and move things around like Scratch, and have if that actually improved, and be able to monitor everything. And also it'll be at some point there'll be teacher functions where you can run it as a classroom. I want to have classroom features where you can send messages to the teacher in the class, so designed for a local area network. You can send like your project, or you can send things to other people in the class, or you can send things to the teacher, and the teacher can send out things to the students. I don't want to make this, I'm not particularly interested in making this a web-based application, because I don't really want, like my experience working with kids, if you give them something where they have to be connected to the internet, they get distracted super easily. And so I kind of want to be able to focus things. So teachers should be able to restrict what the project will let people do. So when I've done Scratch, Code Club, it's very easy for people to get stuck into doing like playing sounds all the time. So I want to be able to say, well, the teacher will turn off the audio features, or they'll turn off certain features until they're ready to be taught, and then they can reactivate them from. So I want to have lots of teacher stuff. But anyway, yeah, going back, yeah, if you like this project and you think it's really cool, please like, share, subscribe. Definitely share it to all the people that you think might be interested in this kind of project. Because the more people are interested, even if I have to live like, on the breadline, I will continue the project if the people are interested. I'm not going to be writing this with any AI. Either AI gets to the point that it could write this app for you, in which case we're all doomed, or it's yeah, AI is another thing that makes me very worried. Like, what is the point of this when AI will do all this coding? What's the point of learning coding? But this will be for now, except maybe for like the odd logo or something, will be no an AI free zone, because I just don't care about getting a computer to do coding for me, because I like coding. But of course, I want this language to be general enough that you could ask like an AI to give you some code in C or Java, and it should be relatively straightforward to change across. It doesn't have for loops at the moment, but it will have for loops in the future. It does have repeat and while loops and forever loops and repeat until loops. Well, repeat until as in the Scratch form, not do until like in the Java form. But I'll add that later on. So a lot of language features, they're the easy things to add in. So don't worry, especially on the Commodore 64 stuff, adding in local variables and returns from functions, which is also something that's missing, is going to be trivial. So I assume that will be trivial in everything else. Anyway, enough talking. I think I've taken way too long in this video. Thanks for watching. It will be fixed. Keep subscribe, and I will do regular updates of my progress, and do tutorials and do in-depth dives into what's going on in the background of a lot of the stuff, and talk about a lot of the things. And it will eventually be open sourced, but it will take time because it's a huge project, and so I will be open sourcing. Some parts of this actually kind of are already open source, and I'll talk about that in another video. But like the first thing I probably will open source will actually be the assembler that's going on behind the back, because it's kind of cool and a bit more focused and simple. Anyway, again, thanks for watching, and have a good evening. I just have to work out how to turn off the whatchamacallit, the screen grabber. Anyway, thanks again. Like, share, subscribe. Bye. Oh, and sign up to my Patreon. Bye.